be honest, I don't think there's much to worry about because you already have headsets. That's the only thing I was going to ask you to bring, but you already brought that, so that's good.
Yeah.
And yeah, so okay, so welcome to the MedTech 101 podcast, Mika. I don't know, do people call you Mika or do people call you Mika-Petteri?
Yeah, they call me Mika or MP.
MP.
Especially the Finns, they call me MP. But but usually
uh,
all the other nationalities they talk about Mika, so I'm
Yes.
fine.
Okay. Perfect. So I'll call you Mika because, like, in
Yeah,
the
yeah,
UK, if I called you an MP, it would basically mean member of parliament here.
yeah. I know.
So, so, so yeah. But yeah. So today we have Mika-Petteri Kuro, who is currently the CEO of Helmee Imaging for nearly the last 4 years, and from what I understand, you guys are based in Finland, in Tampere, which is about two
Yes.
hours from Helsinki.
Yeah. Correct.
Uh, it's quite cold up there. I was quite lucky last year to go to Tallinn, so that's the closest I've been to that part of the world. And alongside this, Mika also works as a sales coach and a business engineer. And from what I understand, as well, you've been working with team sports as well as a coach. And were you a player yourself in any category?
Yeah. So I used to play ice hockey
Hmm. It's quite
while I
big
was
there, I
while I
understand.
was young. Let's put it that way. But well, I still play actually, to be
Nice.
honest. But when I was a kid, I really played like how to like seriously trying to be a professional and so. But that never took off. So I'm
To play in
yeah
the NHL, sort of
yeah yeah
kind of
yeah
level.
like the dream like every other kid as well. So
Yeah, I
so
understand. No, that's really good. And outside of this, I understand that you also are a member of the Helletuspraten
yeah,
Satsakunta. I
that's
don't know if I'm pronouncing it correctly, but how would you pronounce that, and what does
yeah,
it do?
hallituspartnerit. So that's like
Yes.
a because I went through this education, this certified board member
Yes.
thing. So then this organization, this hallituspartner, the idea is that they try to help companies to find good members for their boards, so that kind of what kind of skills that you need in your board, then this
Nice.
organization helps to find those elements there in
And
Finland.
is it a private organization or
Yeah,
is it a
it's
private
a private. Yeah,
organization? Nice, nice. No, that's good. Because I thought maybe the government in Finland was doing that because you always read about what the government does for its people in Scandinavia. It's always seems the government supports people a lot more there than in other parts of the world. So uh and that's good. And I understand you also studied biomedical engineering as much as I did. So I'm trying to figure out how did you go from working in research as what I do right now in R&D to sales, because obviously it's quite different fields. And not many people know this, but I worked in sales for a startup company part time for about 14 months, and we used to meet up on weekends. And one thing that I found quite weird between research or R&D and sales was, I think sales was more flirtatious with people. So in sales you find yourself telling people, this is what we sell. What do you think about this? You email them several times because from what I understood, it takes 3 points of contact before someone actually buys something on average, apparently. So, and then in R&D, it's either the answer is wrong or right. So I don't know, how have you found your sort of like shift from working in research as a biomedical engineer all the way to your job now as a CEO?
yeah. So I studied biomedical engineering as my major in Tampere. At that time, now it's only Tampere University. They combined the three universities here in Tampere, but at that time it was Tampere Technical University, and I really liked the subject. for sure. And then I also continued a little bit as a researcher, but then the project ended and there was kind of lack of funding. So then
Yes.
I found out that there's a job as a software programmer in one company in Tampere. So I applied, and for some reason I got selected. And then quite rapidly after that, the CEO of that company asked me that, okay, hey, I see that you are like a outgoing personality. You like to discuss with people and so on. And to be really direct and honest, you are not very good developer. So how about if you would try in sales?
Yes, I can
So
imagine.
that's how it started.
Nice. And
And
then that's
I
how you
really like
transitioned
that.
to
So
sales?
yeah,
Uh,
that was kind of the transition. And I personally, in my heart, I knew all the time that I would not like to actually work behind some screen typing alone, making these right or wrong things. It's yeah, I know. Uh, because I get a lot of energy while discussing with people, being with them, trying to help them to find solutions for the possible problems that they might have or challenges. And basically, that's sales is very, very, very
yeah,
much like
nah.
that. So yeah.
Yes, and I'm happy you say that because I'm sure like now when you look back at it and it feels like you've now sort of become an all-rounder because you can sit with the technical team and understand the details of how the product should function, the science, the physics behind all that, and at the same time you can also work with the sales team and understand how financial charts work. You understand why it's important to have a budget because I think in R&D sometimes you don't really have that full appreciation of how much it actually costs to get the product onto the market. Because I think in R&D we're just so focused on creating a good product, but even no matter how good the product is, it still needs to be marketed. So I'm happy you say that. And do you think like your understanding of or having a science background has helped you to be like the CEO of essentially a technology company? What would you say?
Yeah, so we are a deep tech company indeed, and we operate with machine vision, and we have some specific arrangement of light, optics, cameras. So yes, for sure, my studies, even though in biomedical engineering, but still anyway, they have been a great help to understand kind of the basics from the physics, really to know at least on a, let's say, deep enough level that how software programming actually works. And I have studied in my university area. I studied quite a lot of mathematics actually. So I'm not
And
very
most of it
good
is
in it.
theoretical.
Yeah, I'm not very good in it. I don't know anymore how to do the Fourier transformation and that sort of stuff. I used to, but not no. But anyway, I think that is kind of very like a fruitful background
Yes.
to lead this kind of a tech company.
Yeah, that's good. And you mentioned the Fourier full transform. It just brought some memories back to me when I was in university, and we're using that for filtering signals from noises and stuff.
Uh-huh.
For increasing imaging quality and stuff. So I guess it might be
Yeah, yeah.
related to what some of the algorithms you do right now. So you might not understand it, but I'm sure the algorithms you have taking all those pictures and filtering all the noise are using Fourier's transform. So now that's good. And and then from my understanding, you before you came to Helmee, you'd already been working in sort of like in sales. You'd left research and stuff. But what would you say? What does Helmi do? Like in summary, if someone asks you, what does your company do? What do you usually say? Because when I looked at your guys' website, I see you put several things you do. You also do like a FAT, which is a factory acceptance test.
Yeah.
And I realized during COVID, you guys moved to doing this remotely. So you set up cameras in your sort of production. And so clients could see without flying to Finland because all the time people had to fly to Finland. And outside of this, you also have the technology which we're going to talk about in detail, which is the covered stereo deflectometry, which I'm
Hmm.
just going to call it CSD to make it
Yeah, good.
easy for people, so I don't have to keep saying the full word. But yeah, I don't know. So, what would you say? What do you guys do in summary? What products do you guys do? What do you offer? And lastly, we'll also touch on the new product you guys launched. I saw it on your LinkedIn page a few days ago, but I didn't want to, to do my research extensively as if I'm writing a dissertation for university, because I still want to maintain that element of surprise. I also want to discover new information on this call, so it doesn't seem like I've been stalking you as much as I've done my research. I don't want to seem like I've been stalking you. So yeah, sorry. So in summary, I've just basically asked you, yeah. So what does Helmee Imaging do?
Yeah. So
And yeah, and what's your background in terms of what's the company's history in general?
yeah, okay. So I'll start with what we'll do. So we do automated quality control for especially for high gloss complex surfaces, and
Nice,
that is like a painted, chrome plated, polished metals, plastics, uh, that sort of stuff. And a good example of such a part that we do the quality control is the automotive door handle. This is just
nice.
automotive
Well,
interior door handle. As you can see, it's relatively high gloss from the lights you
yes,
can see.
it reminds me of the hip and knee replacement implants that I used to sort of work on when I was working at DPU Synthes, which is a part of Johnson and Johnson.
Hmm.
But I understood you guys then do so. I guess your products or your services extend beyond just the well, from what I'm thinking right now, medical technology. I guess what other clients do you usually get then coming to you guys?
Yeah, so far we have focused on the automotive industry and consumer electronics,
Yeah.
but of course the technology itself it doesn't know where it's applied. So we could easily do medical or yeah medical components like let's say artificial joints
Nice.
or whatever like small like uh, some components inside some larger medical equipment, for example, where the surface quality matters. So here, for example, with this door handle, it's only kind of decorative reason, basically. So there's nothing to do with the function. So this
Of
works even
course.
though there would be scratch, right?
Nice.
So, but on the other
So,
hand, if you buy a new car, you want it to be perfect. There are
of course,
you
of
don't
course.
want there to be scratches, right?
Well, the thing about cars, isn't it? Apparently, it loses about 33% of its value the moment you drive it out of the garage. So,
Hmm.
if it's got a scratch, I think it's something you could use against the car salesman to try get
Yeah.
a discount for it. But so so yeah, so I'm actually quite interested to. So in terms of the this CSD technology you guys use to look at glossy objects, um, w- w- would you say what exactly is it looking for? I know like it looks for certain maybe defects, but if you wrote your name on that handle, for instance, you're holding up with a marker, if you wrote the
Mhm.
MP or Mika and you put that in the machine, will it be able to pick that up?
Yes, it could. So
Well,
if
well,
I just I'll use an example. So then
yes,
you get it immediately that when we go to our customers, usually they have people checking the surfaces. So people are doing the inspection that if the surface is good or bad. So what the people do,
nice.
they take the part in their hands, right? And then they look with their eyes to the surface that is it good or bad, make a decision with their brain, okay, not okay, tell that decision to the hands with their brains, and then the hands would either place it into production further or scrap it, throw it away. Okay.
Well,
So what Helmee Imaging does, what is our core? We are the best in the world with the eyes and the brain. So the hands is something that we supply, but the
yes,
eyes and the brain. So
brain.
acquiring image with the CSD technology from this kind of a complex high gloss surface is something
Yes.
that we do better than anybody else in the world.
Makes
And then
sense.
we have the analyzing software as well, uh, done in house. But the point is that this is really in the core. But we still most often we have to have the kind of robots replacing the
Yeah.
hands as well.
Yeah, I saw on your what I'm gonna do is I'll also take some of your when I make this video, when I edit this video and I release it, I'm gonna add some um videos of your guys using the robotic arms and putting it in the DOM as I saw on YouTube so that people can also get a better visualization of what you're
Hmm.
talking about. But would you then say that Helmi is basically replacing the human eye, if not better? What would you say on that?
Yeah, it's true. It's true. And
Yeah.
now so that they say we are not like the bad guys throwing people out from the factories. Actually, most of our customers have problems
Yes.
because they don't find people. So we enable things rather than replace.
Makes
So it's
sense.
a
Of course.
yeah, yeah.
Because most people are worried that the AI and the machine learning and these smart robots that are coming are gonna take away a lot of jobs and everything. So it's a reasonable level of concern that people have. And I mean, people have always had this kind of worries, but what has always happened historically is that as much as the technologies come, some new jobs have showed up as well. So that's good. But then just a quick question then, would you guys say that you could also look at objects that are not shiny or that are not gloss surfaced, besides, or would you just say the algorithm works best with glossy surfaces?
Yeah, we are best with the glossy surfaces. However, uh, lately we have managed to develop things going further and further away from the high gloss
Nice.
items. So, but still, anyway, that's where we are different from many other companies. Is the high gloss items. That's
That's
the
that's your
thing where
edge.
we
That's
differ.
your edge in the market.
Yeah, correct, correct.
And
The history of the
and
company is
then
such that actually
yeah, sorry.
the history of our company is that it was uh, the innovation was originally done in VTT, which is a National Research Center of Finland. So that's a governmental organization doing the
Nice.
basic research, uh, basically for the companies. And since they are not like a company as such to make a business, well, they of course charge, but anyway, so it's their target is not to make business as such. So when they have new innovation, they try to sell that to existing companies or encourage the people to establish a new company.
Okay.
And
No,
this
that's really good. So
that's what
it's
happens
part
for
of.
Helme as well.
Nice. So, like, I can see the government is sort of like encouraging people to form companies essentially by giving them the support through R&D to research their products. But then, what does the government get in return? Do they have a certain ownership, or are they a
Yeah,
minority
this
stakeholder in the company? Or how does it work?
yeah very often this VTT they have an investment fund. Very often that investment fund then has some share of the established company. And then that's a good thing in a way that they also, because they have done this for a while already, they have these relatively experienced guys to help these new entrepreneurs to build the company kind of on the right track.
Nice. So in that case, I don't think you guys will be leaving Finland anytime soon. You won't be relocating to any other uh, country. Or so, from my understanding, you do all your production in Finland, or do you also outsource your production to other countries?
So far, we have done everything in Finland. However,
Well, yeah.
right now we are as we speak, we are looking for opportunities to outsource some parts of what we do. But the actual research and development that happens in Finland.
Nice, nice. No, that's good. And then just one last question regarding just the background of what you guys do. How long have you guys existed? Because I saw on your site you said 2013, so about 10 years now, would you say?
Yeah,
Or the company's been around
it's
for a
true.
lot longer?
No, the company was established 2013 in late October, early November, somewhere there. I was not present,
Yeah.
but anyway, that's when the
Yeah. And I'm sure, like, would you say, in terms of like growth over the last well, since you've been there, is has the growth been rapid? Is there a huge demand for the technology you guys offer, or what would you say
yeah
regarding
the
that? Yeah.
it's this is a, let's say, typical deep tech company. So
Mm-hmm.
it's not like a fancy SaaS thing that you build up something and after 2 years you are unicorn. No, nothing like that. So instead, relatively rocky road, to be honest, and
Yeah, nice.
changed a couple of times kind of the angle that what are we trying to do and how are we going to go forward. Right now, I feel that we are kind of in the turning point
Yeah,
based on the increasing number of requests from our customer base. So it seems that we are there to really to change our 10-year-old company finally from startup to scale up and a real company afterwards. So
nice, nice. No, that's good. And right now you're sort of like in that stage where you are sort of just starting to scale up, would you say,
yeah.
with new clients and stuff. No, that's really good. I'm sure it's taken a long time to get here. Well, a lot of work as well, because it's not easy. And talking about unicorns, yesterday I was having lunch at work, and I was just the day before yesterday, I was in a workshop and we were discussing how, because I live quite close to Cambridge in the UK, and Cambridge is becoming a center of like innovation, especially for medical technology. So,
Hmm.
and we were discussing, some of the challenges people have when they're trying to grow the company, and when they get investments, and especially with the sort of like the venture capitalists, it turns out to be sometimes an emotional decision. So when you start getting companies, pouring money into you guys, other guys don't want to miss out on the fun. So then you got all these people lining up to just pour money into you. But when people start pulling out, then everyone sort of like panics, and everyone starts being conservative, especially with what happened with the Silicon Valley Bank. I think it sent a bit
Hmm.
of like a few ripples across the world in terms of funding and stuff like that. But I think you've done a good job to adapt, especially like what you did during COVID, because you changed something, some part of the business, in terms of how you did the factory acceptance test for your clients, even though without them coming to Finland. Would you say there's some lessons from COVID that have helped you guys? What would you say?
Yeah, well, it's kind of those typical things that what can we do remotely
Yeah,
rather than going there by site, but also in the process part that, okay, uh, that, for example, that factory acceptance testing, okay,
yes.
earlier it was quite like a, I would say, heavy testing. So we built everything like production ready.
Hmm.
And then after that, we shipped everything to customer side, but we had to test that same thing again. So we kind of did
Well,
two times the same work,
and was
which
that double the cost, would you say?
no, it was not double the cost, but it was more like lost time.
Makes sense. Which translates
Uh,
to money as well, at the end of the day, because
yeah,
time is
it
money.
relates, but it was not. Yeah, it does, but it was not double. So,
Well, of course, at least that's good. At least it wasn't double, but at least now
uh,
you can. It means you got a faster turnover time, I guess, than you did before because
yeah,
of
I
this
think
option you have.
I don't. Yeah, I don't know exactly how much faster, but
Yeah,
maybe 10 of the time would be quite close. But the point is that with these remote connections, everything, we do save a lot of time, and then on the other hand, we also changed because of that lessons learned. That okay, hey, uh, we won't do that heavy testing anymore at factory. We just make sure that the system works as it
nice.
was supposed to, but we not really trim that to production level. So it's testing everything works, all safety measures they are there, everything, and then ship that and finally take it into use at site. And this is now the big lesson. It's like twofold. One is that we don't need to do the test full like a fine tuning before shipping. And then the other thing is that also during at site testing, we can use the remote connection. So which basically
Well,
means that our engineers from Finland, they don't need to fly there. We can take the remote connection to the device and then do it like that. So that's
well,
one of the
I think
lessons
that's
learned
really
from
good.
COVID.
That's really good because right now I'm quite fortunate to work for a Swedish pharmaceutical company called Recipharm, but I work at one of their sites in the UK. And one of the things that happens is we manufacture about 1 million components for well, so we make many things, okay, but one of the things we do on my site is we make the what they call the PMDIs valves, which are
Hmm.
basically, for asthma inhalers. They're meter dose inhalers. They just basic, but they have a canister which get attached to them. So but these valves, we make about 1 million valves per day. And it's a 24-hour production.
Yeah.
So, and I think we make about 50% of the global the global market for this particular valve. So it's quite a huge business for us. and
Yeah.
and one of the things that happens is if there's a breakdown, we have to get some engineers to fly over, or sometimes when they need to validate the machines when they've come, they have to fly all the way from whether it's Italy or Finland. And I
Mm.
heard how much it costs to fly engineers to come from a company somewhere, and it actually costs a lot. So when you start doing
Mm.
this, I think it's good in terms of like retaining your customers, because they'll be like, okay, we can go to Helmee. They won't be charging us, thousands for the engineers to come here each time, because they have this platform which allows for remote access and for them to come and look into it. And that's really good, I'd say. And outside of this, would you also say that the machine right now you have for the CDS technology, of CSD, sorry, CSD
Mm.
technology, covers more advantages than disadvantages? I mean, like, why exactly would companies want to use the CSDs technology, in terms of like what disadvantages currently exist right now that this technology is solving? Besides, and
Yeah.
I know I could only think of like eye fatigue. I'm sure maybe the eye cannot really look at shiny objects for a very long time, but
Mm.
is there anything else to that, would you say? Or what have you found out?
Yeah. So basically, just like you mentioned, eye fatigue, yes. But all in all, since we people, we are very good at seeing if something is moving in our corner of our eye, like snake or spider or whatever else, we see that immediately, very easily. But if you start to look at like a steady, shiny object, we are not very good in that. So basically, it means that the accuracy of inspection or control done by people is relatively bad.
Well, makes
So
sense.
we with our technology we can improve the accuracy, which basically means for our clients improved quality.
Nice.
Okay,
Hmm.
and then we are faster than people, not always, but very often. So that increases kind of the throughput, and
Yeah.
then because of the accuracy improvement, we increase the yield. So what they get out from their production, that increases as well. Not always
Well,
again, but very often, yes.
so technically,
So
it adds up. All this adds up, when you look
yeah,
at what the human eye was designed for, well,
yeah,
from an
exactly.
evolutionary biology point of view. So there's
Yeah.
an improvement in terms of that. And when you look at the yield and quality control is crucial. And I guess that's something that's also you can do 24/7, because I was thinking, surely, even if you got humans to do it. They might be good for a while, but as you'd expect, the performance of a human being will sort of like dip over time as they get
Mhm.
tired. They can't maintain that level of performance even if they're initially good. So I guess this then gives that more consistency. And do you roughly know um how much in terms of percentage increases once customers start using the CSD technology in terms of like
So
yeah,
human average, depending on the source, is uh, if you make a test for your quality control people during that test, usually they perform relatively well. But in the long run, the average, according to our customers, it's 70 to 80% is the accuracy, which basically
well,
means that if you have 1 million parts and
yes,
you have people doing the check 200,000 times, they make a wrong call.
well,
So that's quite a lot actually. And
yeah,
then
and
they,
especially when you're looking at a production line, right? Because you
yeah, yeah,
want to
true.
every error adds up down the line. That's one thing I'm starting to see. Like production works as sort of like holistic. It's so if you
Hmm.
got a bad quality material, you see the defects when you're testing it. So it's important to get each stage correct because all those faults like or failure probabilities add up at each stage. So you want to reduce that and sort of like streamline the material or streamline the production or assembly line. So now that's really good. So if 80% is for humans, what's then for yeah the CSD
Yes.
technology? Yeah.
So at highest, one of our clients reached with one single part like 99.97% accuracy, but we
Well,
usually try to make our contracts to 95, 96%.
well, no, that's good. That's good. And do you think the performance? Obviously, I understand it's. Would you say it's based on the complexity of the geometry of the object, or is it based on the size of the object? Because like right now, as I spoke, I mentioned the valves that I use for asthma inhalers. They're quite small. Will this technology perform the same for components that are that small and components that are as big as the door handle you just showed there?
Uh, the, co- the component size does not really matter. It's more about the surface. That if
Nice.
the surface is reflecting, then for us it's a little bit easier then. Uh,
Yes.
and then again, it also what are the kind of the criteria, what kind of defects we are looking for.
Mm.
So if some defects are such like we call them like white on white or black on black, so that
Nice.
kind of the same color, same very like barely visible very faint stuff, those sometimes, to be honest, cause a little bit of a challenge for us too, even though every time we are better than the human eye, but still anyway it's and it's also but mostly it's not the size of the product itself, it's more like the surface that does it make sense. And if you have a
Yeah.
structure there, like a some fabric for example, it's like a small little structure there, so that's why it doesn't work very well.
That makes sense. And but it's interesting the idea of using light as a way to analyze the shape, the structure of components, because in that dome, the idea, the working principle from what I understood is that you take an object, you put it in this dome,
Mm.
and every time I see that dome, it always reminds me of like churches in in
Uh-huh.
Italy or in the Vatican, and then you basically shine the light on it, and then the light is sort of deflected off the
Uh-huh.
object, and it's red on the other side, and then that sort of like gives an idea of where there's a dent or there's a or maybe the shape of the particular device without much error, because obviously this everything is mathematical, so the algorithms are quite mathematical to be able
Hmm.
to perform this kind of analysis. And would you say this is this I'll touch on this and then we can take like a break for like 2 minutes as well. So this will be the last question for now before we take a little break so you can drink some water and here and then before we continue. So the in terms of the advantages this CSD technology is bringing to the market, do you guys have you guys made plans in terms of like your scale up plans and stuff? How have you done it? Because I know in communist China everything was done I think in 5 year plans or 10 year plans. Do you guys are you guys also doing a similar approach to how you're gonna be tackling problems? And what are your thoughts on that in terms of, are you scaling up? How are you keeping your customers? How are you keeping them satisfied? How are you reaching new markets? Is it something you guys are looking into right now?
Yeah, so naturally, all the companies are trying to forecast the future. How are we going? How are we growing? And that sort of stuff. So, and we are doing that too. So, current, currently, if I put it very shortly, what we are doing is that we are uh, selling our solution as a service. That's one thing. So we try to make like 3, 5, or 7 years contracts, and
Nice.
that kind of engages the customer for us. But then on the other hand, enables us to really put some effort for that customer to really make sure that we serve them very well and they get most out of the things that we bring, and vice versa. And then on the other hand, we also look for the markets that okay, uh, our inspection area at the moment is after all relatively small. So even if they make a lot of small parts, still, since our technology does not uh, bring any barriers, we could utilize it for larger items as well. So that's one of the
Nice.
things that we are exploring right now. That okay, larger items. So how large? Is it
Yes.
like a this big, or
Speak.
maybe
Oh, an entire
a
car.
lot
It'd
bigger?
be, it'd be nice to see if you could fit in like an entire Tesla into a dome. I don't know. Have you guys thought of that? Like fitting in something as big as a Tesla into
Yeah, so it's
your
it's it's uh,
technology?
actually you are nicely giving me a good pass, so I can shoot it and score. So what we are doing is since we launched this tunnel like a product, as you probably have seen from our webpage. Yeah, so
Yeah.
that's a or from LinkedIn. That is actually the main difference between the dome and the tunnel is that in the dome, I really need to lift the part into the inspection and then turn it into multiple directions, however needed.
Yes.
While in the tunnel, I can, how do I turn my hand? So I can run the part like through the tunnel, right?
Yes.
So now you can easily imagine that how about if the tunnel would be just bigger?
Of
Then I
course.
can
And I
fit the
think
Tesla there.
And if, I think the tunnel might actually be performing a lot better. Well, not necessarily better, but it'll be faster because you can just attach it to some sort of conveyor belt where things are going in and out, and without the robotic arms of picking up things. So
Yeah.
for bigger objects. So no, that's interesting, and yeah. So
Did you know that you are wasting what could be millions annually? The human eye is not designed to check mirror like parts. Staring at shiny objects strains the eye and bores the mind. That's why we have designed Helmee AOI. It is based on Covered Stereo Deflectometry. CSD is the first automated quality inspection solution.
Okay.
So, so yeah, okay. So back for the second part now. So Mika, would you say the technology? Well, because I see you guys launched a new technology. Do you want to talk about that now? Before we get back to the idea of the dome, or is this new technology part of the dome you're talking about right now in terms of how you guys plan to grow the company going forward?
Yeah, so it's uh, so far all the plans are related to the same core technology, so same innovation basically. It's just different applications of that, and those applications sometimes they might be, I would say, so much different that you really can talk about different products. So, like this tunnel, for example, it's a good. It has the same kind of a principle that the dome. So we still utilize the lights and cameras and optics in a special manner, which is patented for us. So both the dome setup, the tunnel setup is patented. Then we have a third one coming for transparent and semi-transparent items, and that's
Well,
interesting.
and
So
that's a bit more complex because obviously transparent objects don't perform the same when you shining light at them, surely.
yeah, there are some
So I wonder how you guys are going to do that.
there are some specific stuff. I'll
Nice.
just frame it like that. So
Yes,
that patent application is very fresh. So
of course. So you don't
so
have to talk about it right
I
now.
don't want to go into the
Oh,
details, but let's just put it in
of
a way
course.
that the results are very promising.
Nice, nice. I guess I'll be waiting for your LinkedIn post about this one when it's
Yeah,
out.
yeah, you see
And
it.
just out of curiosity, how long does it take for you guys to start from a concept to until you file for patents? Because I know in R&D for for the medical field, medtech, it can be as long as like 10 years or 9 years before the product is good enough for it to be filed for patency. So I wonder if the turnover is a little bit faster in how fast has it been for you guys in terms of
it,
getting those
it
patents?
yeah, it depends on a little bit. So to get like a patent application in, so the patent process goes in a way that you send the application, right? Then there are
Yes.
some review process going on, and then finally after some time you get your patent like accepted, or what is the right term, I don't know, but
Yeah.
anyway,
Approved.
so
Approved.
approved, yeah. So and that might take years, so
Yes.
that doesn't change regardless of where do you operate. However, uh, when we have an idea and then
Yes.
we start putting that together, it depends a lot. So if it's just an idea, then okay, this might make sense. Then we usually, what we do is that we start to look at the markets first before we really that, could this idea really be valuable for potential customers? And if not existing, how about if there are some markets that we are not right now, but
Yes.
some area is there, so that okay, we could go there if we would do this and that. So that's something that we try to do. So
Nice.
because of that market
And
kind of exploration, it
yes.
takes a little bit of time, and some things come faster, some things require a little bit more time. For this, I can say
Makes
that
sense.
for this going from this dome to this tunnel solution, that took I would say probably a couple of years before the actual patent application was filed.
Yes.
However, there was a lot of work done. So basically, the concept and the solution was already there when it was filed.
Meh.
So it
Nice.
internally it was proven already that okay, this works.
Perfect. But now the IP or the intellectual property was now a way for you guys to sort of like cement the technology so that you have that market edge over others.
Yeah.
So I guess no, that's really good. And like I said, I think as we spoke before, I was quite fortunate to have been part of the process of working on creating a device well, building up the machine and filing for the patent. Well, I didn't file for it, but there was the lawyers who do that.
Uh-huh. Yeah.
But when with that patent, with my name on it and four other people I worked with in R&D at the time, and that to get to that point for us, I think the research had been going on for about 7 years, and then we filed for the patent in 20. They filed in 2020, but it was only published. last year in May. So it took 2 years
Mm.
of it going through that process. So you can imagine, and this at this point you still haven't put it on the market yet because you're still trying to protect the technology for yourself. Um, and in that 2 years is just additional, paperwork. They have to check against all the libraries to see if this didn't exist before and everything. Um so it takes time. So
Yeah,
I'm really happy that you got something that came through. You got a second product for the dome, or that's or for oh, there was the dome first, and then now you got this sort of like as we like to call it, the
yeah. We,
tunnel
we call it a tunnel.
technology.
Yeah,
Yes.
yeah. And now the but now since sometimes the development cycle is faster. So
Yes.
like I said, that we have transparent and semi-transparent things coming. So and
Yes.
there's a patent application has been filed. There, the cycle was a lot faster because we had a customer request. So then we just quickly looked at, okay, is there a market or is it just individual customer? And we realized that yes, there is. Okay. So then we started to figure out that okay, how this could be done. And all in all, I think
Yes.
from the first point of contact from the customer side, okay, now we have this kind of a thing, this kind of a challenge in our hands. I think it was like a uh, only some maybe 4 or 5 months that we filed the patent application actually. And the real
Well,
innovation period was even shorter. So the real
of
period when we actually our team members did the innovation was you could count that in weeks rather than months.
well, well, and how big is your team there? Like, do you have like an army of engineers working on this, or you? How many people are in your R&D team? Because from what I saw online, I on your website, you guys said you have 15 people at the
Hmm.
moment, but I'm sure it's potentially more. Or do you have contractors as well? How do you guys manage the human resources there?
Yeah, so inside Helmee, you're right. So we
Yeah.
have 15 people, and not all of them are in R&D.
Yes.
Uh, the R&D team as such, we have like 8 people.
Nice.
Wait a minute, I need
So
to
that's quite a
recalculate
lot. That's quite a
a
lot.
little bit. Yeah, around 8. Let's put it that way.
Yeah, because R&D is always the smallest department usually in most companies. So, in the very first company I worked in for R&D, I think it was full-time people. I think it was about 3 or 4 people that I remember right now on top of my head, and everyone had to do a lot of work there. You had to do all kinds of things to try to create this, and I think it's quite nice to see that you have been able to sort of like get your R&D team to understand the timelines as well, because from what I understand in R&D, you well, as I said before, you don't really get the full appreciation of that the company doesn't as long as the product is in R&D, the company is not making money back from that. So
Hmm.
then companies have this huge incentive to say, okay, we have this product in R&D, how quickly can we get our R&D turnover so that we've got a product that we can sell to sort of get your return on your investment. So
Hmm.
so it's quite nice to see that your R&D team is actually working pretty fast, and making sure that the technology is delivered, because it's not easy to get that, sort of like good link between R&D and sales. But sales is focused on numbers. R&D guys are focused on trying to create the best product. But sometimes you need a product that's to start, and then you can always update it, right? You can always create new
Yeah,
versions. You can always release new versions and stuff. So, and I
that
think this is partially due to your skills as well, from having your engineering background and your sales background again. So it makes you quite versatile.
yeah, you got it right. So what we have done is that we have tried to help our team to understand that rather than building a perfect product, you
Yes.
just first build good enough so
Yes.
that it does what it has to do. That's good enough, and then we can improve, while running. So it's that's kind of the the mental setup that we have managed to get
No,
in quite nicely. So that's a
yeah,
kudos to
no, that's
our
good.
R&D team. They are great. And a little bit back for your
And
previous
yeah,
point,
sorry, continue.
we also use like external uh, contractors or suppliers or partner companies so that they help us so that the actual number of people working around something that we are doing, it might be sometimes a lot larger, but
Yeah.
inside the team is only that size. So
All right, nice. No, that's good. And do you have like some software you use to check when you need to get some guys from outside, or how does it work for you guys? Because one thing we do at work, or what other companies do, is they have this sort of like they call it Microsoft project, and they put everyone in there, and then they've sort of like timelines of what work they need to do. And what then happens is you assign each person, each employee, which is basically a resource, to each task. And then
hmm
when everyone is sort of like being overworked because there's a lot of tasks that are happening, you kind of get the score to say, okay, this resource is being overworked, or this resource is free, so maybe you can then ask this person to help out on this task. Now, how do you guys streamline your process to know, just in general? Because how do you know if it's time to get more people onto the team, whether on a contract basis or on a full time basis? How do you calculate that? Because it's not something they teach in engineering school, so I've got no idea.
yeah, so yeah, if you ask from the R&D team, they always need more people, but 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 the thing is that what we try to do is, first of all, in the kind of in the let's say management level, we try to check
Yeah.
that what are the crucial things that we must do during the next 12 months, 6 months, 3 months, during in some periods of time. And then we just check that, okay, is this realistic? If
Yes.
I say that, okay, some feature, some new element in our product must be done by the end of the year, then I have a discussion with our head of R&D. Actually, his real title is Vice President Technology and Operations. But anyway, we'll check together that,
Nice.
okay, hey, in your team, first of all, do you have the skill set to make this happen? Yes, no. And then even if yes, what kind of bandwidth these guys are on right now and in the coming months? Does it look like it's realistic to expect that this would happen? And then
Makes
if
sense.
there is like a no, then we need to check that, okay, do we need to buy it from somewhere else as a whole, or is it something so crucial
Yes.
that no, we don't want to buy it because it's in our core, so we want to do it by ourselves. Okay,
Yes.
so then it's a question. Okay, then we have two options. Our people are full. Either we postpone it to make sure that it will be done, but it will be done by
Yeah.
our own people, or then we need to figure out that if we have some like temporary stuff, or just hire new people. And
Nice.
it's always in the small companies like us who are there, you know,
Yeah.
trying to find the sweet spot to get the
Nice.
revenues growing and so on.
Exactly.
So then
And
we are
and
continuously kind of in balancing there that everybody is under high workload anyway, but
nice.
it's the prioritizing is the kind of the main task for the management. Okay, what needs to be done now?
True.
What can
So
be
I
pushed for tomorrow?
More exactly. So then prioritizing the tasks, and and would you say you do this on a, so it's, I guess this is quite dynamic. It's something that's always sort of like happening all the time, or is it like a meeting you say, okay, let's relook every 3 months, every 6 months, as to what targets or what objectives we have in the upcoming months, what we have right now in terms of human resources and machines we have, can we reach these targets? And I think it's quite interesting because that's going to be really important with this new products you guys are going to be
Mhm.
launching with the tunnel. And do you have an idea of when the market can expect that, or is it something that's already on the market, the tunnel technology?
So the tunnel is there. We are marketing that actively right now.
Nice.
It's in our sales already, and actually first like what you call them, beta testers or whatever. But first customers, they already have this
Nice.
in their shop floor.
And
So
nice. And are the customers in Finland or abroad?
abroad. So,
Nice. Nice.
but going back to that R&D cycle, so
Yes.
so it's exactly what you said. So it's like a continuous, all the time process. We continuously monitor. However, we
Yes.
do have like a larger planning meeting at the end of the year. We always plan for the next year fully, but
Nice.
throughout the year, a couple of times, like almost like quarterly basis,
Yeah.
we kind of check that where we are, and we made this roadmap for this year. Is it still valid, or did something change? Do we need to adjust that somehow?
True.
Usually not, but we evaluate that anyway. And
Yes.
then the workload and that sort of stuff, that are we on a track? Can we have all these things that we planned? Can we have them done during the period of time we planned? That is kind of
True.
followed continuously all the time. So it's
Nice. Nice. And that's good. And just out of curiosity, how many days off do people have at Helmee or in Finland in general per year? How many days off do you guys get per year
um,
on
well,
average?
this first of all, we have like this 9 to 5 job. So basically, and in Helmet,
So
we have this
you
kind
said
of an
you have nine to 5 days off?
no, no,
Like
no, no.
okay,
Sorry,
sorry. Yeah.
it's like an office job. So people
Okay.
work in
Nine
one
to
shift
five.
only, 9 to 5.
Yes.
But the thing is that Helmet is in my opinion, for many people, I don't know if our guys understand this, but we are very super flexible. So
Nice.
we have guys who work like in a hybrid model already before this COVID thing is. We always said that we don't care where you are.
Yes.
We don't care basically when you do your job, as long as you deliver.
Makes
And
sense.
when we have a meeting, you better be there. That's it.
Which is the
And
most
then
important thing.
yeah. So very like flexible. So if somebody needs to go to take their kid to somewhere or whatever else, then fine, do it. Uh, for example, this week I have been driving my son a lot during the kind of the days that during the time that I should probably work if I would be in such a job that I really should be at the office. So it doesn't really matter.
Yes.
I do my tasks somewhere else then. Then the thing is that the holidays, we have like typical Finnish way. So in principle, there are some like public holidays throughout the year, like in most of the countries. But in
Yeah.
addition to those, people get like 5 weeks in a year,
Wow. That's
and
that's
it's
that sounds like heaven compared to the UK.
yeah. But the in my opinion, the biggest advantage is that in most of the companies, also in Finland, there are certain limits that when you need to have those holidays.
Makes sense.
So
So you have to
so
balance it.
so yeah, and also that for example, you need to have 4 weeks of holiday between May and end of September, if I remember right. This
Nice.
is very often kind of, but we as Helmee, we have said that we don't want you to start kind of collecting that suddenly you are half of a year away. No, you you need to have your holidays, but you can. We are not that strict. You can have it like throughout the year. For just as an example, we had she left already the company, unfortunately, but we had a Japanese employee, and
Yes.
her family lived in Japan, and some part of her family lived in somewhere else. So she used
Yes.
to have holidays like all the way throughout the year,
Yes.
the same amount, but it was not in that period of time. It was
Yeah.
sometime in March, sometime in November, as long as everything was there. So and
No, that's really good.
that is some kind of a benefit that is not really visible to anywhere, but it's just
Yes.
of course we
But
agree always. So it's not like guys just come here today for me that, hey, Mika, by the way, next week I'm going to be on a holiday. No,
Of
it,
course.
it will be agreed before, but still,
Nice.
anyway, we are flexible.
And it's quite interesting you say that because when I worked at Johnson and Johnson, we knew that for our Scandinavian customers, we had to get everything to them before July and August because everyone will be on this sort of like summer break where the nearly the whole country basically closes down for like 3 to 6 weeks depending on the company.
Yeah,
And we always used to look at that with some sort of like envy because everyone would be like, I want to work in Scandinavia. Why am I working here in the UK? Um, because here, on average, just to also give you a comparison of how life is on the other side of the world, here we have 25 days off for the entire year. So that's 5 weeks for the entire year,
uh-huh.
plus bank holidays or public holidays, which add up to about just maybe 8 days. So let's say another. So in total, you have less than 7 weeks you can
Mm.
take off for the entire year, and in some cases you don't even have that flexibility. But do you think having these work conditions, these Scandinavian work conditions, which are nice, does that give you guys an advantage when it comes to competing with international companies? Because like when I grew up in South Africa, my family lives in Zimbabwe, so I'm also like one of your international employee who used to fly back home, and I tried to fly home most of the time, but I find myself having to maybe just take 1 week and work the other week from home, and then I come back, or I have to just shift my days accurately. But I always have to work all the time. So how do you guys then compete with the rest of the world? Just from a bigger perspective, how does Scandinavia compete with the rest of the world when you guys are enjoying life?
Yeah. So, we have one sunny month in a year, so maybe we want to have it off. So that's
Makes
why
sense.
that's why the country is closed in July. No,
Nice.
just kidding. But anyway, it's a fair question you have, and
Yeah.
I think that uh, now that we have international team as well, people working from Germany, from France, from China,
Yes.
and we have international business. So it seems to me that if you really count the hours in
Yeah.
Scandinavia, in Finland, we work relatively little
Oh yeah. Yes.
in terms of hours. But then
Yes.
on the other hand, the work is relatively well organized. So
Yes.
there is also when people work, they actually do work. So they are not
Makes sense.
just you know chatting with friends here and of course
Yes.
there are breaks, and we try to keep it like a so that it's not so it's the atmosphere is still relaxed, but anyway
Yes.
people are really focused that they do what they have to do, and that
Yes.
kind of is one of the strengths. But
Yes.
it's also true that sometimes in some countries having the July off is a little bit of a problem.
Logistically, especially when you become international, because shipments don't stop and everything. But I totally agree with you. And having said that, it reminds me of was it late last year or early this year when Elon Musk took over Twitter, and he let go of something like nearly 80% of the workforce.
Hmm.
But the next day, Twitter was still working. So I guess it's partially because people have less days off. When I look at my friends who work in South Africa, who I went to high school with, they only get something like 15 days off per year,
Hmm.
plus bank holidays or public holidays. So in that's really like you're forced to go to work. So sometimes people get to work. They spend the time on Wikipedia, just reading a few things. No work is actually getting done
Yeah, yeah,
because people are being overworked all the time. Whereas I understand in terms of employee satisfaction in Scandinavia, it'll be higher, and maybe that's what's giving you guys an edge because people know, okay, I work now, I'm gonna have my 3 weeks or my 4 weeks off in the summer
yeah, yeah.
to spend with my family and everything like that. So it's quite nice. And just touching on family and having this quality time, you
Uh-huh.
mentioned that you've been driving your son around and everything like that. on the platform where you do your sort of like speaking training, speaker training,
Hmm.
like you mentioned, like it's something that you value, and from our earlier conversation, I take it to you also a family man. And just a quick question: how do you find that, within just balancing time, with your family and work, and obviously the conditions you have in terms of the flexibility of the work you guys offer at Helmee helps that. But how do you balance the other stuff in terms of the travel and time you have away?
Of course, it's sometimes it requires quite a lot of like pre-thinking that how everything will be organized. Especially in my role, when I
Yes,
don't have any working hours, anything. I'm working in principle. I'm working all the time.
makes sense.
So, however, like you said, I'm a family man, so I'll try to dedicate uh, a big chunk of hours every week for my family, so that I will be there, because in return I will be traveling a lot as well.
Yes.
So just to give you an idea, in Finland in May there was 22 work days
Well,
in May.
okay,
You
yes,
know,
yes.
if
So
I
it
if I
makes
take the
sense. Okay,
weekends
that's
off and
normal.
that's sort of, yeah,
Yeah, yeah, so
it's
that's
normal.
like 4 weeks. That's
Yeah,
four
yeah,
weeks. Yeah.
yeah. So out of those 22, I was traveling 17.
Wow. So
So
that means you're away for nearly 3 weeks of the month.
correct, yeah.
Yeah.
Which so when I'm home, I'll try to make sure that I do have time for my family.
Nice.
So and this May was exceptional. I usually I don't travel that heavily, but anyway, it's just that's the reason why I'll try to organize that I have time for them too. And that goes also throughout the whole stuff, not just for me. I want
Yes.
to make sure that these guys feel happy, so that they are excited about their work. They still
Yeah.
can spend time with their hobbies, families, whatever they want to do in their free time,
Nice.
and so that they feel energetic when they come to office. Because
Of course.
if they
It makes a
do,
difference.
then we of course we get most out of them. So it's as a company. So that's and
And that's good.
after all, if you think about the normal like workday or such, so I'll just make it like that you sleep like roughly 8 hours or so 1/3,
Yes.
and then you work like 8 to 10 hours, however, 6 hours, 7 hours, depending on the day, probably. So 1/3, and then the remaining third should be something that you kind of uh, uh, is for the family or for yourself or whatever, but something that kind of gives you also relaxation. But I don't mean that the work would be burden, but it's just that
Yes.
like two-sided coin, that okay, in the work it must be exciting and rewarding enough so that you feel happy to go there and happy when you go out,
Yes.
so that you have something else outside that hours as well, so that it's kind of the balance is there. Then it's
Nice.
most fruitful for the company and for the individual as well.
Makes sense. And I guess that's the time when you with your family, when you doing your speaker training, when doing when you're a member of the, I still can't pronounce it, the Halluspraten
Yeah, yeah,
Center.
yeah.
And I can't pronounce it. It's just too long. And yeah, that's good. I'm actually taking a bit of advice from that for myself, because I think I don't I think I'm probably not sleeping long enough as I should be at the minute with everything that I'm doing. But that's like some good life advice to look on and just to build, because obviously your career has been going well. I have to take your advice, because you're doing something right, and it's something that I think I can learn from. So that's good.
Yeah,
And
hopefully.
yeah, so then getting back to the CSD technology, um yeah uh, j- with this new technology that you guys are bringing to the market and everything, like what sort of like considerations have you taken for, like sustainability? Do you have components that are reusable? Do you have? I know obviously you've already reduced your the time engineers are required to fly all over the world because you can do this remotely. But is there something else that makes this technology good? Can you reuse certain things? Can you recycle certain parts of it? How does it work?
Uh, yeah. So from the processes point of view, we
Yes.
even though we are in international markets and we need to fly, unfortunately, quite a lot, but we still
Yes.
try to avoid flying always when possible. So we use these kind of remote connections like we are doing now.
Nice. Yes.
However, uh, the product itself that we are building,
Mm.
um, to be honest, we have not put so much effort that we probably could, and we maybe do in the future as well, is to make sure that the components are like sustainably manufactured or so. But what we do have is that for our customers, when they utilize our solutions, like I explained, that they increase the yield,
Yes.
the inspection accuracy is better, and so on. So that what happens is actually that
Yes.
while they make these kind of things, they end up consuming
Yes.
less, a smaller amount of raw materials, energy,
Nice.
and they have less claim handlings, which again leads into less traveling and
Makes sense because
that
there's
sort of
less
stuff. So
failures.
yeah, exactly. So by that angle, we actually
Yes.
have quite a big
Impact.
environmental effect as well,
Yeah,
or
no,
impact.
that's really
Yeah.
good. That's one way to see it. I hadn't thought of it that way because I know it's one thing we're going to be talking on about shortly as to how this technology can be really useful for like medical technology, which is something that I'm passionate about. Is that the number of rejects you get on an assembly line equals the number of complaints you get from customers. So you
Hmm.
have products that are, especially if you're making like millions per day, like as I said, we
Hmm.
make 1 million valves per day. So we try to streamline the process. We in fact we try to design for Six Sigma, and I'll just
Hmm.
explain what Six Sigma quickly means, just for in case someone is listening and they don't have that engineering knowledge. But designing for Six Sigma is basically the engineering zero. Other people want zero failures. In engineering, we say we're trying to design for Six Sigma because we understand that in a production line on the shop floor, we can't really get the numbers to zero. But our engineering zero, we call it Six Sigma, and it means that for every 1 million components that are made, only about three should be faulty, or three we should only have three rejections out of every 1 million. And it
Yeah.
to get to that level, you need a lot of work to do. And I think even for the aerospace industry, they also have I think I've heard of people talking of 9 sigma. I've not tried to calculate it myself to see how many failed parts that is. But those are the things we're trying to design for. And with
Yeah.
the less rejects we have, not only do we have happier customers and or patients, because essentially these are products that are going into they're going to patients. um, it also means that the company has to spend less time troubleshooting, all the money that's used for sending those failed components back and forth and everything. So essentially, by improving that quality control or quality analysis, it actually lessens the impact on the environment, because not a lot of material is getting wasted now. If something is faulty, they can see it in the factory. And I don't know, like for the door handle, for us, we have the option to do what we call material regrind, or they
Hmm.
can melt it again and reassemble it again, and then whilst it's still on the shop floor before it even goes out there, for some of the parts that we make. So I guess in terms of that, that's a good way to see it in terms of what you guys are doing in terms of helping reach this sort of sustainability. And yeah, so like, what are your thoughts like on the future? I mean, it's quite exciting right now. You've got the dome, you got the tunnel, you got the transparent materials coming through. Like, what are your thoughts for the future in terms of are you optimistic, or are you kind of in the middle, or you got other things that are in the pipeline which no one is even has, that you haven't had time to talk about, and that people outside of Helmee don't know? But yeah, so what do you think,
Yeah, so
Mika?
yeah, thank you. By character, I'm optimistic for sure, but it's also something else than just my own thinking. Like I said, we in some phase of the discussion we had that we have increasing number of inquiries coming in. So basically, that means that the customer base is kind of a after our long marketing actions that we have done in the past and now with new releases and that sort of stuff, and also the changes in the production environment through COVID, everything. So it's kind of coming. Things are. I think the puzzle pieces are coming together. So in
Yes.
that sense, I'm optimistic. Also, uh, the all these factors, like we just discussed about the environmental things, sustainability, automation, all in all, lots of people talking about industry 4.0 or
Yeah.
quality 4.0, however you want to say it,
Yes.
it doesn't really matter. They are all something that kind of helps us, our markets, everything.
Yes.
While in many cases, when I go to the factory, the quality control is the last point to automate. So everything else
Yes.
might be automated, but there I see some people still, and the plant managers are thinking that, how I do this, because this is the only point, and it's the main source of all the mistakes we do. So
Yes,
it's a
it's the weak, it's the wink, well, it's the weak link in the chain,
yeah,
basically. So, and
true,
everything
true.
adds up, right?
Yeah, exactly. And then the effect is exactly those environmental things, financial things, all the stress people have. So I've told many times for our possible clients that when you automate this quality control, you really can start sleeping well after that. So
Yes,
that's the
because
only
I'm sure
thing.
the production managers will be happy they didn't have to get phone calls at 3 o'clock in the morning, or
Correct.
about a breakdown, or why is the rejects going up or something. And it's true that you say that, because even at work we still have humans actually visually or physically
Mhm.
inspecting those components. And what they do like a stratified sample. So for every certain batch that's released or created, they have to take a number of samples and they put them in the tray. And one thing I saw on your guys' YouTube was the robotic arms. Well, the
Mhm.
only part a human being is involved in is packing those samples into the tray. And then your guys' robots can do the entire work. They can pick up the components one by one, check it in the
Mhm.
dome, put it back, pick the next one. And that's really saves a lot of time, because now it means you don't have to wait for it's one well it's it saves time in the sense that you don't have to have someone visually inspect that with errors. You don't have someone to double check the work they've done, because you can
Mhm.
sort of trust the machine. Because it's, as you said, you guys try to work for a 95 to 96% confidence interval in terms of what it shows you as being correct, versus the 80% for human beings over
Mhm.
time. So therefore that helps, obviously. And but do you think there's a possibility that that it could even start packing? Well, I'm sure a machine can do that, can pack the samples itself, and then the machine will check. But at what point would you need a human being in the quality analysis, besides just packing the samples into the machine for it to do for it to do its job? What would you say in terms of where would humans be still needed, for those people who are worried that, oh, this technology is replacing them? Can you how can you reassure them that at some points humans are still needed in this process?
Yeah. So first of all, somebody needs to take care of the unit itself. So there
Yes.
needs to be an operator
Yes.
anyway. After all.
Yeah.
Not very often in interacting, but anyway, still there needs to be an operator. So that's one thing. The other thing is that in some customer cases, we actually, what we do is that we check or control the part, and if it's okay, we already put that in the delivery box, like a carton box. So our
Nice.
unit actually does the packaging as well. So,
Yeah.
but
That's smart.
yeah, but then in painting processes, especially,
Yes.
they do a lot of rework. So basically saying that some of the defects that we find, they are such that they actually they want to kind of take off the paint and then do the repainting. Uh, and again, that's a good thing. So rather than just scrapping the part, they would try to make sure that it still could be delivered in a good quality. So that's where people are
Needed.
needed
Yeah.
to. Well, of course, everything could be automated, but in real life, it's I was I was in China, so basically what you could do there in a hotel, that was quite funny actually. I could order food from whichever restaurant.
Yes.
Somebody brought that in the hotel lobby, and then there was a robot, and the guy put that into the robot, and the robot started to move into for example, my room in seventh floor or
Wow.
whatever else. And then it came to the room. I got the announcement in my mobile. Like, oh, okay, I have food there. I opened my my door, and
Though.
okay, I took it from the robot, and then the robot goes back. So basically,
Uh,
everything can be automated. It's not about that. But
yes.
then it's just that, okay, what does make sense?
Yes.
So in certain tasks, it's still
Yeah.
better to have people, at least for the time being.
Nice. Makes
So,
sense.
but for the surface quality control, the thing is that if you really think about automation as such, so what are the things that actually should be automated, right?
Yes.
So they are like the things that are repeating many times,
Yes.
uh, and then they well, that's the first thing. You need to have a repetition in place, and then hopefully relatively simple and like a monotonic task, so that there are not, there is no where you don't need human senses, like you don't need to smell or hear or feel something. Then the automation is in place. Machine vision handles the eyes already, no problem there. Probably there are some microphones as well for the hearing, but so
Yes.
I seen that happen too in one factory. What they did is that there was some piece of metal, and they wanted to find out if there's a crack inside. So they
Yes.
clapped the metal somehow with another metal, and then they have microphones there. And if the tone was somehow different, then they had a reason to believe that, okay, there's a crack inside. Let's scrap this part,
Yes.
melt it, and do it again. So microphones are there as well, but I don't have any information if the smell is there or feeling,
Of course.
haptic feeling. So, for example, here quite near in where I live in Tampere area, there is a
Yes.
factory making big engines, and that's highly automated factory. So they really
Yes.
they have pushed really like advanced technology there. So when they put together a big engine for some tractor or truck, uh, there are barely any humans involved. But
Well,
in some specific tasks, there needs to be a human touch, so that
makes sense.
you for example, some bolt that they put in, they don't tighten that, but they since it's it's continuously different, so it's
Yes.
always it's like same but different, so it's always in the same position, but you need to feel that is it like working. So what
Makes sense.
happens is that the worker actually does something a little bit, and then the robot comes afterwards and tightens the screw.
Well, as a sort of reinforcement. So I guess that's good because if anything, I don't think the machines will replace us entirely, but they'll make our lives a little bit easier than what has been happening. And I think that's how I see technology in terms of how it's been growing. It just makes our life a lot easier.
Hmm.
It allows us to use that time more because I always say that with all these machines coming, maybe this would be an opportunity for people, especially in this part of the world, to also start asking for more days off, because you don't have to be at work for as long as possible, because the same output now can be done in a much shorter time by a smarter robot. So working conditions will improve, more benefits for people, more time to spend with family. People are already talking about the idea of a 4-day working week, whereas like just 100 years ago you only used to get Sunday off in this country,
Hmm.
and you had to work on Saturdays. And
Yeah, yeah.
all this has been able to happen because of how technology is growing. And one thing as well, just to touch on before we go, just looking at the time, uh would you say that the technology you guys offer has, the capacity to do some sort of like metrology work? Like, can we take measurements with this light? Because I understand light is also quite um accurate, because you know how the wavelength works, whether you want to see a light
Hmm.
as a wave or a particle. That's a joke I'll leave to do with my physicist and engineering friends. But can you also take measurements of the dimensions with this technology? Is it possible to do like to take scans that can be fed into like 3D printers from this same technology? Since virtually this is an eye, right?
Yeah. So far we have not done really the like dimensions measurements.
Yeah.
However, uh, we could do that too. There are ways how to do it. Uh, Yet, yeah, it has not been such a big problem for our clients that we would have started to do that. And it's a little bit also now it goes to the automation that if you have a complex
Yes.
shape like this, so you can see that there's like a different angle here than here,
Yes.
and when you look at the light, it actually depending on the angle, you see the light in a
Yeah.
different way, right? So it's very like
Yes.
critical that or crucial that in what angle and what position this is, and
Makes
that
sense.
has an effect for the dimensions measurement as well,
True.
because we capture different signals. So now
Yes.
I'm not saying it's impossible. It's just
Yes.
it requires quite good software work behind so that it can tolerate small little changes and
Yes.
still do the very accurate dimensions measurement.
Nice.
And this is for the complex parts. If the part is simple, then there's no
Yes.
problem. But
Yeah.
that is one of the key reasons why we have not done this yet, even though we know
Yes.
that it could be done.
Makes sense. And that's like food for thought, maybe for your pipeline
Hmm.
at some point in the future, to start looking if this can also be used for like metrology, like
Mm.
things that need to be measured to concise parts, especially for us, because we when you look at an asthma inhaler, it's relatively small, but the components that go in there are small, so it's quite crucial we get the measurements right, to the millimeter. Even we look at like point zero 0.01 millimeter, I think, correction or something like that.
Mhm.
And for some of the smaller components, we even look at smaller scales. And I personally, when I was in engineering, I didn't think I'll be working to pay that much detail to really small components, because I thought it's something a watchmaker does, but for engineering as well, it's quite important as much as the big components. So that would be nice to see how well it also, if you can have that functionality and stuff. And I think, and for medtech, um, I think this technology will be even useful for just looking at the defects there, as I said, because it's gonna be it's gonna be important, especially for implants, for the because in medtech we tend to treat different devices differently. So the higher the classification, the more people want to be confident with what they're doing and stuff. And especially for hip and joint replacement implants,
Mhm.
especially if they're custom made, as we start to move towards personalized medication, it's something that you guys could have an input for that. But I don't know if you've started taking into consideration the amount of regulatory requirements for medtech, because it's a highly regulated industry, like the aerospace industry. And for your clients that you've had from medtech, like what kind of questions have they been asking for? From what do you think? Is that the next sort of market for you guys, or?
Yeah, that's at least I'll just put it in a way that it's one of the next opportunities.
Yes.
I don't want to go deeper in that where are we going to, but
Yes.
it's one of the opportunities for sure. Um, about still for the dimensions, I would say that right now we have in our hands one client who is willing to also check the dimensions of a part.
Yeah.
However, that's for us that's easy. We can do it no problem because that specific surface that they are willing to measure the dimension, that's flat.
Yes. Yes.
It's flat. So for us, that's
It's easy.
it's easy. There's no problem there. So
But when
kind
it
of
starts getting complicated, with like I don't know if you've seen the joints, the implant joints. Some of them look like that door handle you've showed me there.
yeah,
They've got
I
some
know.
weird shapes, to try to replicate how the bone would have been shaped here, or
Yeah,
and talking about that, I think it's even important to see, um, i- like I would say that if you guys have a good, sort of confidence interval, which you do have, which is like in the 90s percent in terms of quality control. And you can see, particularly for metal modes, you can see where there's defects, such as maybe there's a dent with this technology. But are you guys also capable of looking at the the device and saying, okay, maybe there's a little crack there? Does your technology also look at the cracks? Because
yeah,
if it does, that's also another potential for you to actually make it even more related for medtech. And I'm just sitting here thinking, how can I convince you to even focus more on medtech? Because maybe because I got a bias, but yeah, this is going to be life changing, especially for devices that potentially fail. Because most of the failures that happen with medical implants, such as those hip implants, or the implants they put on the femur, which is the longest bone in your body,
hmm
it they tend to have structural failures. So they tend to either break and stuff. And I feel like, and this is also because when they make the metal, maybe there's some faulty parts in there that people can't visually see. And if your machine can predict that, okay, this kind of looks faulty, this will be an area of high stress and this will crack, like in terms of mechanical stress. In if that can be picked up in production, it's gonna make a huge difference. So it's something for you guys to think about and
yeah,
see if you
yeah,
can start
yeah.
doing that.
Yeah. So basically, by the way, what we usually do is that
Yes.
we'll request potential clients. Okay, hey, send us some samples,
Yes.
and hopefully those that have some kind of a defect that you need us to find. So then we can, in a quick manner, just to say that okay, is there any reason to talk further, or is it just that sorry, we cannot help you. But uh, and that being said, we have done these kind of tests with, for example, knee joints, and
Yes.
I know we can help there. So we
Nice.
I
I'm
know
happy
that
to
already.
hear that.
The crack thingy,
Yeah.
if it's visible on the surface somehow, then
Yes.
yes. But
Yeah.
I'm not familiar with this problem at
Of
all.
course.
I cannot
It's
say too
some
much.
of the stuff, the thing is with cracks in metals, some of them they can be visible on the surface, but they are hard to see with the human eye. Because
Mm,
I don't know if you've seen these videos on the internet, maybe not, but like on Instagram they have this um pages where people just put this sort of like satisfying videos, like where you see like a metal which goes into another metal. So it's technically two metals, but because
mm,
the precision where it was cut to is so thin, when you look at it from the human eye, it looks like it's one block until someone
mhm.
pulls out another piece of metal. So in theory, on that surface, there's a little crack. or a little
Mhm.
gap, but which our eyes can't see. And some of those things can easily go undetected in quality control, in especially when it's done by a human eye. So, and I think depending on how many mm, um, microns the technology can focus, of which light has like capacity to even look at something further, that could be potential error. It's okay, there's a tiny little crack here or something like that, but I'll leave that up to you guys, engineers. But that's something that potentially even could also add value. So yeah.
Yeah, so
um,
I could make a comparison.
yes,
For example, in automotive, there is a
yes,
suspension rod. So
yes,
it's a rod, like a metal
yes,
rod, and it's covered with hard chrome.
yes.
What happens before the chroming is that they do some grinding work for the actual metal,
Makes
and
sense.
then they make the surface there with hard chrome. So our system, we can see the grinding defects through the chrome basically because they are
Well,
visible. And the reason for that is that the actual surface is super thin,
yes.
and it usually it doesn't kind of fill the holes in the body material. So if there is a defect in the body material, it's visible also in the surface usually
Well,
in
yes.
chrome plating and painting.
Yeah.
If this is the case there, then maybe, but let's see.
Yeah, no, but yeah, thank you very much, Mika, for coming on the podcast. I really appreciate it.
Yeah, thank you for inviting. It has been a funny time to chat with you, Rodney, and lots of interesting points from the medical technology side.
Yes, thank you. All right. Okay, have a good day.
Thank you.